So the next one would be by hot concentrated acidified KMnO4. So let's see what is going to happen in that. First of all, for this hot concentrated KMnO4, there are some rules. What are those rules? First is that both pi and sigma bond will break. Both pi and sigma bond will break. And second is that if double bond carbon has two hydrogen, if double bond hydrogen has two carbon, then what is going to happen? Then CO2 will form. Third rule states that if double bond carbon has one hydrogen, then carboxylic acid will form. Then carboxylic acid will form. Will form. This fourth rule states that if double bond carbon has no hydrogen, then what is going to happen? A ketone will form. Ketone will form. So you have to memorize these rules. These rules, they are very important. Okay?
Okay.
Yes. And now let's see what is going to happen in them. Let's take some examples related to it. We have this unsymmetrical compound. So if you can see that here it is having two hydrogen and here it is having one hydrogen. We just have to see those atoms which are basically present between the double bond. Okay, they have the double bond. So this is basically the reactive part. So we just have to see them. So now what is going to happen? That first of all, there's addition of oxygen here because of acidified KMnO4. Then there is hot concentrated KMnO4, MnO4. Yes. So as it is having two hydrogen, so there'll be the production of carbon dioxide. Okay. As it is having one hydrogen, so there'll be the formation of carboxylic acid, and we know it would be CH3C double bond OH. Okay. And there'll be the
Okay.
production of water as well along with it. Is that clear?
Yeah.
Yes. So because of this double bond, carbon dioxide would form. And because of this single bond, a carboxylic acid would form. And there's a production of water along with it. Now, this is first example. And now let's take another example. So if we are having this kind of a compound, so you can see that there is no double bond. Oh, there is no hydrogen. There is no hydrogen. which is attached with it. Okay. So because of that, what is going to happen? What is going to form here? A ketone will form. So ketone will form like this: CH3, C, double bond O dash CH3. So we know that the two bonds will form like this. And if we are going to add like this oxygen here, and then there is hot concentrated H positive and MnO4. So what is going to happen? You can see that a ketone will form. Why I'm adding two here? Because there are two same kind of substances that are attached with this double bond. Okay, that is why I have attached two here. Is that clear?
Yeah.
Yes, so this kind of a ketone, this is basically ketone. We know the carbon is here, so this is basically a ketone will form at this point. So we just need to remember this thing, okay?
Okay.
So this is whole about our alkene lecture. And now let's move further towards halogen alkene. So let's discuss about them in detail. First of all, we know that this is carbon and it has made a bond with fluorine. They are belongs from group 7. They belongs from group 7. We know group 7 elements are fluorine, chlorine, bromine, iodine. Okay. So now this is basically fluorine and this is bromine, and now this is iodine. So let's first discuss about their electronegativities as well. The electronegative values are like this. First of all, carbon is having the electronegativity of 2.5, while the electronegativity of fluorine is 4. For chlorine is 3.5, and for bromine is 2.8, and for iodine is 2.6. So you can see one thing from this, that the difference of electronegativity between carbon and fluorine is maximum. Okay, you can see carbon is having 2.5 and fluorine being the most electronegative uh, in the whole periodic table. So they have the maximum electronegativity difference. So can we say this thing, that CF being the most polar one, most polar one, and CI being the least polar one. Okay. So
Yeah.
can you tell me now that which one is having the weakest bond? Which one is having the weakest bond?
CI.
Yes, Ci is the one which is having the weakest bond because of least electronegativity difference. So it is having the weakest bond. So as we have studied this thing before as well, that the reactivity of group 7 elements, they basically decreases downwards. Okay, so we know that uh, uh, first of all, if we discuss about reactivity, so we must know that fluorine is the most reactive one, then chlorine, then bromine, and then iodine. So we know that we have studied this before in O levels as well, that fluorine can displace chlorine, chlorine can displace bromine, and bromine can displace iodine as well. Okay, so we must need to memorize this thing that the weakest bond is between this carbon and iodine. Okay, and one more
Okay.
important thing here, let's discuss about the general formula of halogen alkane, and that is basically CnH2n plus 1 X, where X tells us about these halogens. Okay, so this is basically the general formula for halogen alkane, and how we actually name them. First of all, let's see about their naming as.
You know the electronegativity. Do we have to memorize these values? 4,
No, no, no.
3.5, 2.8, 2.6.
Basically, you will be given this electronegativity table. So there is no need to memorize them. Okay.
Okay.
After that, let's see about some of uh, the structures, how to name them. So this is chloro, this is hydrogen, hydrogen, hydrogen. So how we are going to name them? It would be chloro, chloromethane. It would be chloromethane. Okay. So what kind of reaction would be possessed by halogens? Let's discuss about their reactions now. So reactions of halogen alkane. Let's discuss about their reaction. Either they can possess nucleophilic substitution reaction, or either they possess elimination reaction. Okay, so let's see
Okay.
about this one. And before going further, I just want to tell you about what are, I just want to describe you about primary, secondary, and tertiary halogen alkane. So CH3, CH2, CH2, Cl. This one is basically alpha carbon. Why we are calling this as alpha carbon? Because there is only one alkyl group that is attached with it. You can see there is one alkyl group. This is ethyl group. So one alkyl group is attached with it. So we are going to call it as primary halogen alkane. And remember, alpha carbon is the one that is basically attached to this halogen. Okay, so this is alpha carbon. And let's take the example of secondary halogen alkane. If this is the condition, so this one is alpha carbon, and now it is attached with, you can say, two groups, two alkyl groups. So it is basically called as secondary halogen alkane. Is that clear?
Yes.
And now, if we are going to have this one, CH3, C, CH3, Cl. So this one would be called as tertiary halogen alkane, as alpha carbon is basically attached with three alkyl groups. So it is called as tertiary halogen alkane. Now, let's move further. So,
I have a question.
Mhm.
So what if the alpha bond is bonded to two al these CH3s, but the third bond is with something else? Will it still be
Yes, yes.
tertiary, or will
Okay. You are saying that, sir, this is basically CH3 group here. And if it would be C2H5 group, so would it be secondary halogen alkane? Is this your question?
yes?
Yes, it would be secondary halogen alkane. Okay.
Okay.
So now let's move further and let's discuss about uh, primary carbocation. And then we are going to have secondary carbocation. And then we are going to have tertiary carbocation. So primary carbocation is the one which is basically attached with one alkyl group. Okay. And secondary carbocation would be the one which is basically attached with two alkyl groups. It could be same or it could be different. And this is basically tertiary carbocation. So can you please tell me that which one would be most stable?
Um, is it the tertiary?
Yes. And why it is more stable?
Um, I'm not sure actually.
Okay. So I have told you before that these are alkyl groups here are electron donating. Alkyl groups are al are electron donating. And what they tends to do, they will be giving their electron at this point, which makes this carbon more stable. Is that clear? Which makes these
Yeah.
carbon more stable. And why they are giving electrons? As you know, that carbon is basically having these three bonds, and there is one electron which is vacant here, okay, which is free. And it is basically giving its electron at this point, which is making the charge on this carbon, you can say the electron density on this carbon lesser. Okay, that would decrease the electron density at this point. Is that clear?
Yeah.
Okay, so let's move further. Now we have the reactions of halogen alkane. First of all, we are going to have the reaction of hydrolysis. CH3, CH2, and then we are going to have Cl. So hydrolysis means addition of water. So I'm going to write water like this, and this reaction is going to be proceed in heat reflux form. And what is that? I'm going to tell you now. First of all, what is going to happen? This OH group will go at this point and H would react with this one. So it is going to form CH3, CH2, OH plus HCl. Let's discuss its structure as well. And this is Cl, this is H, this is OH. We know OH is basically a nucleophile. We have already learned this thing that OH is the one which is having negative charge with a lone pair, So carbon here is carrying partial positive charge, chlorine is having partial negative charge. So what is going to happen? This OH nucleophile is going to attack at this place, and this bond will move towards this place. Is that clear? So
Yeah.
what is going to happen? OH is going to attach here. So it is going to form OH would attach at this position, and H, we know H is having positive charge here and Cl is having this electron, because this electron here at this point would move towards this chlorine. So now they would also combine and would be forming HCl. Is that clear?
Yeah.
So now your question might be, sir, what is meant by heat reflux reaction? So heat reflux is basically this kind of a thing where we have a flask at the bottom. Okay. So what is going to happen? We have put the reagents here. We have put the reagents here, and there is a
What's meant by regents?
reagents means these are reagents, the chemicals. Okay. So these are reagents that are basically reacted together. So we have,
Does it mean reactant?
yes,
The
we
same.
can say reactants as well.
Okay.
Yes. So what is going to happen? There is basically, you can say uh, this is basically, you can say a type of a condenser. What is the purpose of condenser here? Hot water, this is basically cold water that is entering from here. And this is basically, I'm going to draw it like this. This is basically cold water would be entering from here. Hot water would be leaving from this place. Okay. You can see here. So what is going to happen when vapors are going to form? Vapors would move up like this. And what basically condenser would be doing? Condenser would be condensing these vapors and they would be coming back here. They would be coming back here. Why we are using this heat reflux reaction? We will only be using this kind of reaction where we want that reactants should be having more time to react together. Is that clear?
Yeah.
Again, I just want to describe it that basically vapors are forming at this point. Vapors tends to travel upward. And here, what is happening? Cold water, there's a condenser here. So cold water is basically entering at this place and hot water is basically leaving from this place. So what is going to happen that these vapors, the vapors that are formed, that would be condensed at this place, that would be condensed at this place, and they would be coming back. And why we are using heat reflux reaction where we want that reactants would be having more time to react together. Is that clear, Sultan?
Yes. So the condenser is filled with cold water.
Yes, in condenser, remember, there's a continuous operation that cold water is entering from this place and hot water is leaving from this place. There is basically a pipe here. There's a pipe here and water is filled
Okay.
at these places. Let me just tell you that water is basically filled at these places. These are the places where water is filled, these places. And in this pipe, we are going to have the vapors. In this pipe, we are going to have the vapors at this place. Is that clear? So these
Yeah.
vapors, they would condense and would be coming back. And continuous operation would be going on that cold water would be entering and hot water would be leaving from this place. Okay?
Okay.
Hmm.
Yeah.
So this would be the heat reflux reaction. Okay, so let's move further and let's discuss about second reaction that is going to be with CH3, CH2, Cl, and now it is going to be react with NaOH and it would be in aqueous form. Again, this reaction would be conducted in heat reflux. So what is going to form? This OH is going to react at this place, and Na would be reacting with this Cl. So it would be forming CH3, CH2 dash OH plus NaCl would form. Is that clear?
Yeah.
Okay. So remember one thing here, I just want to tell you, this is aqueous metal hydroxide. So remember one thing, that in this halogen alkane, aqueous metal hydroxide, they would be giving, a substitution reaction. They would be giving nucleophilic substitution reaction. On the other hand, there is alcoholic metal hydroxide. We are going to use that later in this halogen alkane. They would be giving elimination reaction. They would be giving elimination reaction. Okay, so we have to memorize these things. So before we have discussed about aqueous metal hydroxide, and later we are going to discuss about alcoholic metal hydroxide. So there's one more reaction. Let's move further, and that is CH3, CH2, Cl, and it is going to react with ammonia. And now we know ammonia has lone pair here as well. So what is going to happen? This amine group that would come here, and this Cl would react with this hydrogen. So, and remember one thing, the important thing that I'm telling you, this is the only reaction that is not conducted in reflux state. That is just conducted in heat, and pressure would be given to it. So the formula would become CH3, CH2, and NH2 like this, and HCl would form here. Is that clear?
Yeah.
Okay, so let's move further. So now we have another reaction, and that is CH3, CH2 dash Cl, and now potassium cyanide, which is in alcoholic state, is basically reacted with it. So what is going to happen here? This CN will move at this place, and K would react with this Cl. So it would form again a substitution reaction, CH3, CH2 dash C. We know carbon and nitrogen is having triple bond, okay, like this, and it is going to form KCl like this. Is that clear?
Yeah.
Okay. So now let's move further and let's discuss about uh, primary halogen alkane. Sultan, just give me 1 minute, please.
Okay.
Now we are going to study about primary halogen alkane. Primary halogen alkane, they are going to undergo SN2 type of nucleophilic substitution reaction. What is SN2 type? I'm going to describe you later. So when there is a reaction CH3, CH2, Cl, and it is reacting with sodium hydroxide, and now we are going to discuss about its mechanism. We have already done this reaction before. So it is going to form CH3, CH2, OH plus NaCl. And we know that this reaction basically occurs in heat reflux state. So now what is going to happen? Now you have to memorize this mechanism. that this is basically CC. We know it's hydrogen, 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 and this is hydrogen here. This is hydrogen here. And we know that this is basically Cl group, which is attached here. So what is going to happen? We know OH group having a lone pair here with a negative charge here. So what is going to happen that it is going to come at this place. Okay, as it is having a partial positive charge, it is having a partial positive charge, it is having a partial negative charge. Okay, so what is going to happen around here? Just let me make this one as like this. H is here, H is here. So let's make Cl here, okay? Because if we are adding OH here, then Cl should be here. Okay, we can also write it like this as well. So now what is happened that we know it is having partial positive charge, OH is having partial negative charge. So it is going to come here, and what happens that this bond is going to break like this. So what is going to happen? This is basically a slow step reaction. And now what is going to happen? This is C, this is H, and we know that OH is being coming here at this point with H here, and this is like this is H here, and this is Cl here. So what is going to happen? It is going to break like this. This is C, H, H, and this one is H. Okay. You have to show this step as well. Very important step. So
Okay.
we know OH comes here as it is having partial positive charge. It is having negative charge. So it is going to make a bond at this position. So what is going to happen in the final step process? And that is that carbon, hydrogen, hydrogen, and this is, we know OH group will come here, and this is C, this is H, H, and this is H. And now what happens? Cl, we know these electrons when come at Cl, so Cl is going to have a negative charge. Is that clear, Sultan? So this
Yes.
is the mechanism that you have to show, and why we are calling this as SN2 type, because two molecules are involved in it. Two nucleophiles are involved in it. This is first nucleophile and this is second nucleophile. So they are going to be involved in this reaction. So that is why we are saying that primary halogen alkane will undergo SN2 type of reaction. Okay. And one more important thing, the rate of this reaction. Okay, they might ask you that the rate of this reaction that is basically dependent on OH minus concentration, and the other one is this CH3, CH2, Cl concentration. Is that okay? So we have discussed this thing that rate of this reaction basically depends upon the concentration of OH ion and this molecule. So let's move further towards tertiary halogen alkane. Before we have done primary halogen alkane, and now we are going to do tertiary halogen alkane. So what is going to happen here? This is CH3, CH3, this is CH3, and there is Cl bond here. And this is tertiary halogen alkane. Why? Because alpha carbon has three alkyl groups. So it is going to be reacted with sodium hydroxide in heat reflux reaction. And what is going to happen? This OH would come at this place and Na would react with this one. So it is going to form like this. This is a general kind of a reaction. And let's discuss about its mechanism. Now, you can see that what is going to happen here. This is carbon, and let's draw its complete structure like this. And this is basically, it is having partial positive charge, partial negative charge. This is OH ion, okay? This is OH ion. And what happens, as we know, it is a bigger molecule. So OH is not having enough space that it is going to attack on this electrophile, okay? So what is going to happen that OH here is unable to attack electrophile. And because of that, what is going to happen? Now let's see that if OH would be unable to attack at this place, then first it is going to have another reaction. And that reaction is that we are going to put this CH3, Cl, okay, in the polar solvent, in the polar solvent. We are going to put it in a polar solvent. And what is going to happen because of that? This is basically a slow step reaction. And in polar solvent, two anions would form. This one would be, this is CH3, this is CH3, this is CH3 with a positive charge here, and chlorine would be removed like this. And now, what is going to happen? We know this is tertiary carbocation, which is quite stable. And now it is going to react with, and now it is going to react with another, this OH ion. Now it is going to react, and this one would be a fast step reaction, and it is going to form the bonds like this. Is that clear, Sultan?
Yeah.
And remember one thing, that this kind of reaction that are basically possessed by this tertiary halogen reaction, tertiary halogen alkane, that is basically SN1, because only one molecule is involved in this reaction. Is that clear?
Yeah.
Okay. So the last reaction that we are going to discuss now, and that is with alcoholic metal hydroxide. And I have told you before, the alcoholic metal hydroxide would undergo elimination reaction, would undergo elimination reaction. And let's see how it is going to process. So this is basically an halogen alkane, hydrogen here, this is carbon, hydrogen here, this is a chlorine group, and this is hydrogen. We know the one, the carbon which is attached with halogen, that is basically alpha carbon, and the one which is attached with this alpha, that is beta carbon. And when it is going to react with this NaOH, which is in alcoholic state, So what is going to happen around here? This Na would come and would react with this chlorine like this and would be forming NaCl, okay, and with the production of water as well, because what is going to happen around here, that this hydrogen would also be removed and it is going to react with this OH and would be forming water. And now after doing this, remember, double bond would be formed, would form between alpha and beta carbon. So how it is going to form? It is going to form like this, double bond carbon, this hydrogen, this hydrogen, this hydrogen, and this hydrogen. Is that clear, Sultan?
Yeah.
Okay. So this is whole about a lecture which is basically related to halogen alkane. Okay. And in the next lecture, we are going to do some past paper questions.
Okay.